In this lesson, I just wanted to review some of the transformations of functions that you're going to need to know in order to complete the Section 2.5 assignment, as well as how you should be solving problems on your test. So this first slide shows all of the transformations and some hints for you as you're going through and you're applying the different transformations. So this first grouping we are the X effectors, because essentially what's happening is that the graph is shifting or changing somehow in a horizontal manner. And what that means is that our X coordinate is what's changing. So the first two would be our horizontal shifts, so we would shift left and shift right, then we would have our horizontal stretching and shrinking, and then we would have our reflection about the y-axis. One thing that you want to observe is the fact that everything that's happening with these horizontal changes is the numbers are being operated on the inside of the parentheses. So we have an x plus c is inside, x minus c is inside, c times x, and then negative x. Everything's on the inside of the function. In terms of what that means for our order pairs, you want to think of it like you're doing the opposite operation, and it's always going to be applied to your x, again, your x effectors. So, for example, if we have a number being added inside that first horizontal shift, that's going to shift the graph left, which might be the opposite of what you think, which really means in order to find the answer, we would be subtracting the number from x. So inside, it was x minus c. Or sorry, excuse me, on the inside it was x plus c, but what we're actually doing is x minus c. Same thing then for our second one, is that if we're shifting right, on the inside, the way that we see it, it would be x minus some number, but when we actually do it, it's going to be x plus the number. The y-coordinate would stay the same for all of these. Your horizontal stretching, we would divide the number by c, the x by c, but some people like to think of it as multiplying it by the reciprocal. Either way, but I'm keeping it consistent as x over c, so that way we can see it's the opposite operation of what you would think. Inside the parentheses was c times x, but when we come over here to actually do it, it would be x divided by c. The opposite of multiplication would be division. Same idea for the horizontal shrinking. Just understand that with your stretching, it would occur if your number is between 0 and 1, and that makes the graph wider. For horizontal shrinking, the number would be greater than 1, and that would make the graph thinner. The last one would be a reflection over the y-axis, where we have a negative on the inside. That's going to change the sign of x. So again, those are our x effectors, horizontal changing, horizontal movement, but what's happening is the opposite of what you might think, opposite of x. So the next grouping would be our y-effectors. This would be any vertical changes that we would have, vertical shifts, vertical stretching and shrinking, or a reflection about the x-axis. For these ones, we're going to be changing our y values. That's why we're calling them our y-effectors. The good thing here is that you're actually going to do that operation to y. So for example, in our first case, we have a plus c on the outside. Plus c on the outside means that we're going to add the c, so plus c to our y. So again, we're adding, subtracting, multiplying, or changing the sign of all of our y's, and they're on the outside. So if it's on the outside, then we're going to be applying that same operation to y. Our x's would stay the same here. So if it's on the outside, we do that operation to y. A vertical shift up would mean that we're adding a number on the outside. A vertical shift down would be that we're subtracting a number on the outside. Vertical stretching means that the graph's going to be taller, and that would be for a number that's greater than 1, which would hopefully make sense. And then vertical shrinking would be a number between 0 and 1, which would make the graph shorter. A reflection about the x-axis would be a negative on the outside, which again would then flip the graph over the x-axis. So in general, because I know it's a lot to remember, if the number is on the outside of the function, we want to perform that operation to the y-coordinates. That's this last grouping that we just saw. The number is on the outside, do that actual operation to the y-coordinate. If the number is inside or within the function, perform the opposite operation to the x-coordinate. So outside, do the operation to y, inside, opposite operation to x. In Professor Messenger's video, he did give you some examples of transforming some common graphs. So I wanted to do one where it would be a graph that you might not have seen before, or we don't have an actual specific function that we know any of our common graphs. Before we get into that though, it is important that you understand that with all of those transformations that we just went through, the order does matter. So when you're doing multiple transformations at once, you need to make sure that you're working in the correct order. So first, we would perform any horizontal shifting. So that would mean if we have a plus or a minus inside, moving the graph left or right, that would be first. Then next, we would be doing any stretching or shrinking. So that's vertical or horizontal. You're going to be doing that next. Third would be any reflections, again, over the x-axis or the y-axis. And then last would be our vertical shifting, which would be a plus or a minus on the outside. So why don't we apply this sequence as we work through the next example. So in this example, we want to sketch the transformation of f of x on the graph provided, explain all transformations in words, show the ordered pairs for each transformation, and any other necessary work. So what you want to do first is look at what you're given and figure out what's happening in terms of numbers being added, subtracted, multiplied on the inside and on the outside. So don't worry about the order yet. Really, it's probably best to just move from left to right in terms of looking at the problem. So first, I see that we have a negative, and the negative is on the outside. So a negative on the outside, going back to our list, means that that would be a reflection over the x-axis. Then next, I see inside the parentheses, I have a 2, and that 2 is being timesed. So a times 2 on the inside means that we would have a horizontal shrinking. So it's a horizontal shrinking since the 2 is greater than 1. So going back to your chart. And then last, I see that I have a minus 3 on the outside. So a minus 3 or subtract 3 on the outside means that that would be a vertical shift. And we would be going down since it's subtraction 3 spaces. So in words, that's each of the 3 transformations that we have. So now, in order to move forward, we need to figure out which is the order that we need to do these transformations, because again, the order matters. So looking back up at our sequence of transformations, the first question is, do we have any horizontal shifting? So horizontal shifting would be if we had a number being added or subtracted inside, shifting left or right. So looking at our list, I don't see anything that would show a horizontal shift. So we don't have the first one, so we're done there. So then our next step would be to see if we have any stretching or shrinking. Well, we do. We had that times 2 inside, which was a horizontal shrinking, so that's going to be our first step, is doing the horizontal shrinking. Next, we would want to do any reflections. So here we said that we had a negative on the outside, which was a reflection over the x-axis. That would be second. And then last would be any vertical shifting that we have. That would be our minus 3 on the outside. We said that was a vertical shift down 3 spaces. So that's the order that we're going to work through this. Anytime you're performing a series or a sequence of transformations of functions, you want to make sure that you start with the original points in the graph. So that's what we have in the table here. So looking at our graph, we had negative 4, 0, negative 2, 4, 0, 0, 2, negative 2, and 4, 0. So, like we just said, the first transformation that we would be performing would be that horizontal shrink. And that horizontal shrink, going back to our chart, has a general form for our ordered pair as being x over c, comma, y. Well, c would be whatever number was being multiplied, which in our case was the 2. So I'm going to fill in this table to show that we're actually doing x over 2. Our y is going to stay the same. So if you want to fill that in now, we definitely can. So that this was 0, 4, 0, negative 2, and 0. So in that way you don't get confused. And then in order to get my x's, I'm just taking each of the x's that I already have and I'm dividing it by 2. So we had negative 4 divided by 2 would be negative 2. Negative 2 divided by 2 would be negative 1. 0 divided by 2 would be 0. 2 divided by 2 would be 1. And then 4 divided by 2 would be 2. So what this table shows would be just the transformation of the horizontal shrink. since we had that times 2 inside. So that was first. Now the next transformation that we do is going to end up being our reflection over the x-axis, since we had a negative on the outside. Whenever we're doing our next transformation, we always work from the table that we just had. So in this case, when we're doing our reflection over the x, that general form for our ordered pair is x negative y, because again, we have a negative on the outside, so a negative outside means that we're doing that to our y. So a negative y would be in here. So our x's are going to stay what they were from the previous table. So that means this is going to stay -2, -1, 0, 1, and 2. But now our y's are changing. And what's going to happen with our y's is they're just going to change sign. Well, first we have 0. -0 is the same thing as 0, so that's going to stay. 4 would become -4. 0 would stay 0 again, -2 would turn to +2, and then 0 would stay 0. Finally, we have our third transformation, which was our vertical shift down 3 spaces. So again, looking back at our chart, our ordered pair for vertical shift down would be x and y minus c. So in our case, the c was 3. So in here, that means this is going to be y minus 3. So again, our x's are staying the same. So going back to what we had for our second one, our x is going to be -2, -1, 0, 1, and 2. And then I'm going to be subtracting 3 from each of the y's from our previous table. So I would do 0 minus 3, which would be -3. -4 minus 3, which would be -7. 0 minus 3, which would be -3. And then next we would have 2 minus 3, which would be -1. And then we would have 0 minus 3, which would be -3. So what this table shows is the order pairs that represent g of x, that original negative f of 2x minus 3. That's what we want to graph on the table to the right. So we're going to plot each of those points. So I'm going to have -2, -3. I'm going to have -1, -7. I'm going to have 0, -3. Then I'm going to have 1, -1, and 2, -3. So it is important that the shape stays the same, and remember we did have a reflection, but on the left-hand side of the y-axis it looks like sort of a parabola, so when we're connecting the points we want to keep that shape, and then on the right-hand side it looked like a V, so we want to keep that shape as best we can. And again, you can check this visually and say, okay, from the original graph, we needed it to shrink, so hopefully the picture looks smaller. We needed it to reflect over the x-axis, which means that it would reflect downward, and then the graph would move down 3. And if you follow that from the original, we should get this same answer.